So these last couple of minutes, like I said earlier, I just like to hit on a couple of things just because sometimes they can slip through the cracks. So the first point I want to make here is that when it comes time to making a warning decision, you want to base them on base products as much as possible. And so when I talk about base products, what I mean is reflectivity, differential reflectivity, specific differential phase, correlation coefficient, storm relative velocity, base velocity, and spectrum width. Now, I always have to put this caveat in there that some radar folks will say, well, KDP isn't a base product. Well, technically, it is not the most basic representation of the data. That would be just differential phase. But differential phase in and of itself is very difficult to interpret meteorologically. It's okay for data quality analysis, but for looking at the weather and trying to figure out what's going on, it's not always the easiest thing. Specific differential phase is a lot easier with that range derivative applied to it. So we look at that as the most basic way to interpret the data meteorologically. Likewise, storm relative velocity, back when it was a separate product that was sent out by the RPG, yes, we kind of understood not calling it a base product, but nowadays all SRM is something that's done in AWIPS where you put the storm motion in, it gets subtracted off. So it really is the base velocity data. It's just got that simple adjustment to it. And especially when you're talking about certain types of storms analysis, it really is comparable to looking at the base velocity product. So we included it with the base data analysis. Now there is one caveat to it that I'll get to here, though, in a couple of minutes. The flip side to the using base products for issuing warnings is to avoid rules of thumb. Specifically, you don't want to rely on derived products based upon different relationships that maybe have come up in the past or on that particular day. Like a common one that was traditionally done was the concept of the VIL of the day, where when you have your first storm and it's severe, it had a certain VIL value when the first severe report was issued. Oh, okay, I'm going to use that VIL value to help me issue warnings. That runs into a problem if, say, like you have a situation like this where that first VIL value was, say, somewhere in that 60, 65 kilograms per meter squared range, and you've got like 6 different storms that have VIL values of that. But at the end of the day, only one of them actually ends up producing severe weather in the near future. So, you can really run into problems with that. And it's kind of goes back to what Justin kind of mentioned earlier, where you want to make good meteorologically defensible decisions. And so not using rules of thumb and relying on the base data is going to be the best way you can do that. Now, I mentioned a moment ago about storm relative velocity. The big thing with using the SRM product is you always want to make sure that the storm motion you're using is representative. Now, on the storm relative velocity product, you can always look up into the legend. If it's a display in the upper right, you'll see it on the upper right. If it's loaded up into, like, say, a 4-panel on the upper left, the legend will be up here in the upper left. But you'll always see the information about the storm relative velocity. So in this case, you can see that we have a storm motion of 239 degrees at 19 knots. And in this case, it's pulling that motion from the WarnGen track. So it's using the last storm motion you use when you issue a warning in WarnGen, and that's where it's coming from. Now, in addition to that, you can also pull the velocity from the storm track product. And so that'll give you an average of all the storm motions from each of the centroids that were identified by the STI algorithm. And so you can use that. A third option is going to be to just use a custom user storm motion. And this can really be helpful if you have a situation where maybe it's an environment that's conducive to splitting storms. So depending on whether you're issuing a warning for a right mover or a left mover and you're looking at rotation or storm top divergence, you can look at it specific to that particular storm's motion. Likewise, if you've got upscaling going on or some other things where either the last warning issued or the STI really isn't going to capture it well, using a custom defined motion will help a lot. But you always know where you can look at it there, and then knowing where to set it, it's going to be under the Tools menu. And when you pull up the Radar Display's Control GUI, it's going to be located towards the bottom of the window, and you've got the 3 different radio buttons you can use to select and choose. For the custom store motion, you can use the slider bars to set it. But it's really important because this is, we've even noticed in the AWIPS proficiency exam when people take it, this is one of the more commonly missed questions that people have, is that they're not sure where to go to set store motion. So we really try to hit it as often as possible just so that you're comfortable with it and you know where to look for it. Now, the last set of things I want to hit here is really just in terms of data quality in general, that whenever you notice something odd or unusual in the data, Justin pointed out a handful of them earlier in those cases, you always want to make sure that you're looking at the right products to try to diagnose what's going on. Some things will be relatively easy to spot if you look at the right products. Sometimes even looking at the right products, it's still going to be hard. You might have to pull in either your radar focal point or reach out to the ROCS folks to just kind of help out. But if you look at the right products, it at least gets you on the right track to figuring out what's going on with the base data. So in this particular case, like if I just highlight, you can see you've got a data artifact on this one radial, and it shows up in correlation coefficient. And you can see some elements of it in the other products, especially a little bit in CDR, but it definitely stands out most in correlation coefficient. And in this case, when you look at it in correlation coefficient, especially when you look at reflectivity and you see these large values here, and that in KDP you can see you have really large KDP values, greater than 4 degrees per kilometer, you have a pretty good feeling that what you are seeing is some form of non-uniform beam filling, because non-uniform beam filling will impact correlation coefficient, where it degrades the data and it basically ruins the correlation coefficient value for the rest of the radial. Now, even though you see something in ZDR, there's probably something else going on. And here, I'm going to pop up this second one just so you can kind of get a better example of this. You can see if I pull up ZDR, you can see there's almost a similar artifact in ZDR where you have a drop in the ZDR values. And then if I highlight it in the other parameters, you see a similar thing in CC in some places, but not others. Now, in this case, what we're seeing in ZDR is differential attenuation. And it just so happens that the physiological things that cause differential attenuation and non-uniform beam filling can happen in the same places a lot of times. So a lot of times where you see non-uniform beam filling, you may also see differential attenuation, but you won't always. Sometimes you'll only see non-uniform beam filling. Sometimes you'll only see differential attenuation, just like you do in this area here, where you've got a pretty broad area where the differential reflectivity is dropped, but you don't really see any signal of it at all in correlation coefficient. Even in this area here further to the south, you've got quite a bit of a drop in ZDR, but it's really only a radial too that's impacted in correlation coefficient. And these are just important things to know as you try to diagnose problems. Is you want to make sure you look at the right thing so that it helps you figure out exactly what's going on. And even something along this lines where we're looking up much higher in the storm, where we have some issues of depolarization streaks, and kind of impacting this area here, where you're kind of getting these alternating streaks of low and high ZDR values. This is something that's going to be related to electrification, causing orientation or preferred orientation of your ice crystals. Now, just because these streaks are occurring all the way across, it doesn't mean that the electric field is doing that throughout that whole echo. It's really just impacting it more towards the front where you start to see these things set up. But what happens is because you have these oriented particles, the beam hits it, some of that horizontal or vertical pulse gets transferred to the other polarization, and then just like with non-uniform beam filling, it basically corrupts the signal for the rest of the radial. So, knowing how to look at the data and try to diagnose these things can be a big help if you notice it in real time, especially with some other data quality issues that can come up that may be a little less common than the ones that I'm talking about here. And so, yeah, just kind of skip ahead. So with all of that, we've reached the end of the session, and fortunately we got done here right about 2 hours. If you haven't done so already, please feel free to move on to the winter and the convective storms, or I like to call it severe topics, so you can work through that so you can get to the next ILT before you go to the workshop. We talked a little bit here when we tried to present some kind of hands-on way of doing things here, but realize that when you get to the workshop, you're going to get lots of opportunities to put some of these concepts into practice, and people really start to, with all that practice, some of these ideas really get cemented there. So, obviously you'll get opportunities working on some of the WES exercises and this next ILT, and even the pre-workshop primer that you'll do before you come here. Those will help with some of those things, but really when you come to the workshop, over those 5 days, a lot of these ideas will really harden in your mind, and it'll help a lot.